And then we're half past the hour, and as I mentioned at the start, we're super honored to have Adam and Eoin back. As you remember, they both briefed us prior. Adam is from NVIDIA of physics fame. He's done a lot of work for USD physics. Eoin is from Microsoft of Havoc fame. Has done a lot of work for physics, glTF extensions. And they have just a few slides to share, and then some discussion. So whichever you want to do the screen share, let's go for it.
Can we see that?
Yep.
Yeah, so we myself and Adam just kind of discussed what we'd like to talk about. We came up with a pretty rough agenda. Mostly we'd like to use this as a bit of feedback on like what people think, or what people are going to implement, whether we can get some extra excitement going, that sort of stuff. So we got a bit on compatibility between USD physics and glTF, the MSFT rigid bodies spec. We do know there are some differences. Some of those are related to the file format itself. Some of those are just different, just as a result of different people writing it originally. Then we've got some updates on some changes, and then just open the floor for some feedback and questions. So the last time we had this call, there was a lot of discussion about triggers and trigger shapes. So a volume in a physics simulation that will detect when overlaps occur, which is very useful for implementing sort of application-specific behaviors. And there's nothing in the spec that describes particular behaviors relating to those, but they're a useful thing to describe. Now, USD does not have those in the USD physics spec. And we've been discussing this with the USD group, with Pixar, and there's a bit of resistance there. I think that the feeling is that they're a more general concept rather than a physics concept. But a lot of the feedback I get from people using physics simulations, I think maybe Adam, would you agree with me?
Yeah,
they're still very useful physics.
It is very useful for physics, and it's a very common physics thing to do in practice. And indeed, from basically David, who represents Pixar in our very informal and consensus-based working group, is that yeah, nonetheless, this should maybe be a separate extension and not be physics specific. Now that's tricky because we want to be able to tie these triggers to physics. Normally that's how they are used. So oftentimes they're like attached to a physics object and so on. So, you know, doing it in a separate extension where then we would also create a dependency on the physics extension if we wanted to do that kind of flexibility. But in any case, because we are kind of in that working group, we only generally add things to the spec if we have consensus on them. If as long as, you know, there is a strong objection, it's not going to happen. So we're kind of stalled on that.
Yeah, so we need a good idea. We need some way to merge those concepts at least. Joint drives, and this is my own fault really. In joints in USD have motors and drives. We haven't prescribed any for glTF. I just have not had the time in the last few weeks, unfortunately, to add that. But I think what's in USD is good, and we intend to mimic that. And that's useful for making physically based animations, driving ragdolls, driving animations, that sort of thing. So it can get a lot of really nice effects from those. A couple of other things, and I grouped these two on this slide together because I think they're kind of tied into the way that USD composes files and can compose new scenes from multiple USD stages. So USD has a mass properties that you can add to an arbitrary node, and then when you're constructing your rigid body, you'll take the aggregate of all of those mass properties. And that allows you to have another USD stage that pulls in sub-resources from a like template asset, and you might only want a subsection of that file, and you still want to get the mass behavior, the mass properties. I don't think glTF has a similar sort of issue, just because it doesn't have this scene composition. So we're considering just flattening those mass properties when we convert between USD and glTF, which means you get the same behavior physically, although then you're potentially losing if you go start with an asset in USD that has these mass properties, put it into glTF, and then pull it back out into USD again. I know that's not the path that we were talking about with the interoperability. You do lose information there, unfortunately. So we've discussing whether this is how useful this is in USD, and whether it's worth.
Maybe my comment on this one is, indeed, we really maybe at some point I thought maybe even went too far in USD physics with being able to specify masses of shapes that then sum together to create a single rigid body, and then the masses of those shapes get summed up to derive the rigid body mass. We haven't really used that very often so far in practice. It's either we just don't specify mass at all, and then the system just computes the volume of the shapes, and then based on material-based density, we derive a mass. That's the most common use case we have. Or you can just set the total mass for the entire rigid body, regardless of what shapes it's composed of, if that's something that you know. Now, maybe a bit of a spoiler, getting ahead of myself in this presentation. Now that we're looking at how to map like CAD files, where you have very complicated aggregation and very deep aggregation logic, basically you're always like taking different parts, and when you bolt two parts together, those get aggregated, and things are specified on the individual pieces. Maybe actually this is a good idea. This is just something we haven't discussed this, Eoin. This is just something that's like really recent that I'm looking into right now as part of my job. But yeah, there's a big conversation to be had here, what the right level of abstraction is, because certainly it's legitimate to think about these things as the schema does not need to have complicated logic to derive mass. The schema itself does not need to have a mass calculation logic. You could take the stance that basically the schema only specifies per rigid body mass, because that's the only place where it's really needed. And then the tooling is responsible for doing all of this aggregation and summation, and as a kind of intermediate operation that doesn't have to kind of reflect down into USD at every point, only at the end result.
Yeah, so open questions there. Then the other thing, again, I think this is quite similar to the way, or quite reflective of the way USD composes scenes, is USD has explicit pairwise filtering, so you can specify a path to a rigid body or geometry, and you can say these objects do not collide. USD also has the kind of group-based filtering that the glTF physics has, and you can emulate pairwise filtering via unique group names to some degree, but I don't know if it's desirable to have in the glTF spec to have a pairwise body filtering method, if it's something people would like. I see it as sort of, because of the way that USD scenes and stages get composed, you want to be able to, in your parent scene, explicitly prohibit collisions between certain pairs, that each individual scene doesn't have any context of the other. It isn't aware of the other, but the parent scene does. So if anyone does have a desire to have the pairwise filtering, I'd love to hear from you. It's a little bit trickier just because of the paths. Like obviously USD, you can specify full paths to nodes, and the glTF is just indices based. So there'd just be a little bit of kind of management there. But that's probably the other major difference that we have in terms of the functionality. In terms of incoming functionality that we've been discussing recently in our USD group, we're talking about adding pairwise materials. So the materials that are specified in both specs are obviously a dramatic oversimplification of how the real world behaves, but good enough for most simulations. And the glTF physics spec has a set of combine modes for materials, just very basic, maximum, minimum, geometric average, and USD does not have those. So I wonder, should we remove them from glTF? But one of the things we were talking about was explicitly adding a material per pair, which can be a little more representative of the real world. Like you can't easily say when rubber meets ice, this is the coefficient of friction it will have. So it's out of a drive to have that. You can't mathematically describe a model where you can combine any two materials and get their friction restitution values. So we had a desire to say, listen, given these two explicit bodies or these two explicit materials, this is the value that should happen when they combine.
I would personally actually be in favor of doing both, because the combine modes are very practical and convenient, and there's better combine modes than the USD default, which I believe is average, if I remember correctly. And that's the only one that you get right now. So it's oftentimes it's practical to be able to have like a minimum function, for example. But none of those are going to ever have like proper, let's say, engineering rigor, because ultimately when you look up these things in tables that have measurements, the frictions friction coefficients are between two different surfaces that are interacting. And I would like to soon propose a revision and an update of the USD physics schema where it's possible to have to specify basically sparsely, but say that, if you know exactly what the coefficient of friction is between, let's say, rubber and concrete, then you can say what that is, and you don't have to try to derive it with a mathematical formula or do it by averaging the hypothetical rubber and the hypothetical concrete coefficient. So and of course, if you don't specify it, it would then fall back either to using these combined modes or just the average, which is the current behavior.
Yeah, so the kinds of scenarios we're seeing that be useful is people making very serious simulators that need this additional accuracy. So it feels useful for that kind of respect, but it does add significant complexity to the material handling, or the runtime at least. But I'm all for making physics programmers' lives harder, because that's me, at the expense of making artists' lives easier. Another thing we're talking about is tapered capsules and truncated cones. So these two shapes, we have cylinders and capsules right now. We've had a request to have them support different radii. So truncated cones can make actual cones, and tapered capsules are very useful for character joints, character limbs. Obviously, we'd like to, it's quite easy to add that spec into the glTF. In USD, it's a little bit harder. Oh, sorry, was that a question? Nope. Okay. It's a little bit harder in USD just because USD has geometric primitives out of the box for these shapes. It has a USD geom prim for spheres, boxes, capsules, cones, cylinders. So that actually has side effects on the larger USD spec as a whole. In particular, the graphics guys we need a bit of consolidation there, and that'll have side effects on the tools. But it's something I'd really like to see us get in at some point. And then another thing I've been asked for in just meetings and discussions around the glTF physics spec is whether we should add an additional transform onto the geometric primitive. So right now, if you specify a sphere, it's just got a radius, for example, and that's located at, that sphere is associated with the node, and that node, the sphere is at the origin of that node. It's the same in USD, very similar for capsules, cylinders, boxes. I was asked if we can support an additional transform for those shapes. And it's useful in some scenarios. Obviously, it can be emulated by adding an extra child to your hierarchy anyway. But it does feel like it kind of subverts the idea that a node is the thing that's supplying the transform anyway.
Actually, let me comment on this one too. I've actually hit this case also just recently, where we have our use case where we're basically not allowed to change the hierarchy, the USD hierarchy for reasons, and indeed, for example, the layer composition system of USD, it lets you do a lot of things, but like you cannot change the hierarchy in layers. So changing hierarchy is a pretty intrusive operation in USD, unfortunately. So that's why workflows that require changing the hierarchy are not really good workflows. And we are hitting this in several places. And one of those places is when you would like to shift a shape like this a little bit to the left, a little bit to the right, and you realize you can't do that without changing the hierarchy. That's basically a scenario we've also encountered. And therefore, I agree with you, Eoin, this would be nice.
Yeah, so I mean, I know I did kind of say that it's not great because it subverts the nodes, but for mesh shapes and convex shapes, there's already this implicit offset that's built in because they're generated from triangle data, which can have an arbitrary offset from the node. So it's really just the geometric primitives that we're worried about, and it feels like it would make those closer to the mesh and hull shapes.
And that kind of a modification would be important also for the inertial tensor. So having offsets on those primitives seems like a reasonable idea to entertain from my perspective.
I mean, basically with tools that are doing like automatic geometry fitting, like imagine you want to fit these let's say tapered capsules to a little skeletal guy, and you realize that tapered capsule is just with like identity transform, it doesn't fit perfectly, so you want to shift it and you can't, so that's annoying.
Yeah, not without adding an extra node, which
exactly. Yep.
Yeah.
I just want to address the question from Aaron in the chat where he asks, why not just give those geometric primitives an additional node to give it a transform? And I just want to point out, like a little redundantly, that it's an additional physical property in the sense that if we offset, like looking at the cylinder on the screen right now, if we offset to the bottom of the cylinder, the inertial tensor will be different. But if we have to rely on a geometric transform to know what the tensor is, then we have to ascribe like a physical meaning to the transform that isn't there presently. So having it in the hierarchy doesn't really help at like this fundamental mathematical level. And the alternative would be, instead of using the cylinder primitive, make a mesh and physically offset the vertices of the mesh. But when you have like this lovely little primitive that takes 64 bytes to describe, it would probably be kind of nice to be able to offset. Like I can see an argument there.
Yeah, and again, the thing about, right, like sometimes you just don't get to do that because you don't, like, it really, like, production stupid reasons, like you don't have write access to that layer. Like you don't get to write your base layer, and you also don't get to change it by adding a transform in your in the higher level layer that you do have write access to, because that's just not something that USD supports.
I want to caution about offsetting meshes to do these kinds of transforms, though, because as soon as you do that, then it becomes a lot harder to discover instancing or make use of instancing. So whatever we do here, we should keep that issue in mind. We've had large data sets where, you know, we have 40,000 of the same thing, but they're meshes, and they have rotations that are burned into the point positions, and it becomes very difficult to take advantage of the fact that they're really all the same thing.
Yeah, I think at some point that has to be dealt with by like the actual implementation of the physics engine, right? Whether you build a compound shape with multiple levels of hierarchy, or you flatten them into a single hierarchy and concatenate all the matrices, which typically tends to be good for performance anyway in the physics engine.
Yeah, but I guess what I'm saying is in the source specification, you want to maintain the fact that there's a transform instead of burning that transform into the positions of points on a mesh. Because once it's burned in, you have to try to infer it back if you ever want to take advantage of the possibilities of instancing. So I wouldn't want to do something that encouraged people to burn transforms into mesh point positions.
Yeah, but I think we are in agreement there.
Yeah, I think we're only suggesting this for the geometric primitives, so sphere, capsule, box, cylinder.
But if you do that, you were just saying you don't need to do that for the mesh because you can burn it into the mesh points. I'm saying I think it should be everywhere designated as a transform. Now, maybe what you're saying is the transform, this is a special kind of transform, and we need to distinguish between transforms that are part of a traditional scene hierarchy and transforms that happen because physics is moving things around.
Yeah,
I mean, I think that's kind of the direction that you know, Adam was going in, saying that there are various constraints at authoring time that make you want to create a hierarchy in one particular way, and physics may have other needs. And instead of, you know, the way things are mostly built today, we insist on one hierarchy, but maybe we want to think of this sort of issue in a different way, that there's an authoring hierarchy, and there are some other transforms that physics uses to move things around, and those don't, you know, necessarily all have to fit into a single scene hierarchy.
Yeah, I might point out there's any number of solutions. Like when you build a transform operator stack on a primitive, there's things like transform op, or there's transform op and rotate op and scale op. Conceivably, you could add rigid transform and rigid scale and rigid orientation without going so far as to introduce like a whole new hierarchy. So I think there's a bunch of ideas that we could probably discuss on that front.
Yeah,
right.
And some of these.
I guess I just wanted to add that the other thing that makes it a little bit incompatible is that physics generally wants to work in world space, not in the local space. So you can have something that's, you know, part of an assembly, and you've scaled the assembly, but yet physics wants to move it around in world space, but the authoring system would want to still adjust it in the local coordinate system.
Aaron in the chat says he'd like to respond.
Yes, I've just been waiting for there to be just a second of people not talking, and that hasn't happened yet. All right, so I would like to respond to Nick and Adam. So Nick, you said that the shape offsets would be important because that allows you to have like the inertia tensor not be relative to the center. But we already have the distinction where the collider shape can be on a child node, and that is separate from the body. So there's already support for that.
That is a geometric consideration rather than a physical property consideration. But yes, I see your point.
And I'd like to respond to Adam as well. You mentioned that like there may be situations where you want to be able to change the offset of a shape without like having right access to that hierarchy. And I'm really confused about this because I don't know of any situation in which you would want to be modifying the imported file to be completely different from what it started out as, while simultaneously not having right access to that. If so, why not just make a copy of it? It
Well,
seems like
with
really
USD, we
bizarre.
are layering these things, but we're almost out of time, and there's like 3 more slides. So I think this maybe we could discuss this some other time. But
I think we
this
need
gets into some
to.
pretty complicated workflows.
I think we need to reserve an entire MSF meeting, a whole hour for this discussion. There's a lot of discussion. I have a lot of things on my mind, and there's no chance we can get to all of it in 3 minutes.
Mm-hmm.
Yeah, I just to give you the 1-sentence version of the answer to your question, you may have authored an asset and you don't want anybody else to change the nature of the structure in which it was authored, and yet you may still want a physics simulator to be able to move things around under the influence of physical forces, and you don't necessarily want to have to make a full copy of something just in order to do a physical simulation on it.
But if you're doing a physics simulation, you'll be moving the bodies, not the shapes.
Yes.
Why don't we hold?
We can go. Yeah, we can.
Why don't we hold this for water cooler if we can go over afterwards?
Yeah, good call. So Adam, Owen, do you want to go back to you for the rest of the slides, and we can, as long as people can stay on, we'll just keep it rolling.
Yeah, sorry, I didn't realize that would be so controversial.
No, that's why we're here. It's all good.
So yeah, let's blast through the other ones. As Marco kind of described, there's project ramping up to actually get started writing code for USD to physics or USD to glTF converter. So obviously I'm keen to get involved there. That will obviously, myself and Adam have worked very closely together throughout all our USD calls. And we're pretty confident on all our compatibility claims, so it'd be great to actually validate them and also use it as a motivation to get some more sample assets and stuff. And this last one here, Adam, this was your
right. So this was what I was alluding to earlier, that in CAD, like, even something like a home appliance is made out of just like lots and lots of parts, right? Like all the little screws and so on that hold it together, that ultimately oftentimes just make it a single rigid body. Like imagine something like your I don't know, coffee machine. Like it's just like one thing. Okay, you can remove maybe some parts, but let's say that a lot of it is just it's all bolted together, but it's modeled from like, I don't know, like over 100 different little parts, and they are basically like subtrees and assets in USD, or at least that's how I've seen it. And the only way how you can make that work with USD physics right now is basically by having those individual asset parts be rigid bodies and then creating fixed joints between them that actually create like solver constraints under the hood, which makes the simulation of something that ultimately only ends up with 6 degrees of freedom incredibly expensive and costly. And basically it's we would need to support either like fixed joints that don't actually create constraints but aggregate rigid bodies, but we have like problems implementing that, or some other kind of aggregation logic in USD physics. So this is just something that is like a current problem on my mind, and maybe we need to deal with it somehow.
Okay, and then I'm just going to blast through glTF tooling. I've done a bunch of work, not as much as I'd like to recently. Got a validator for MSFT rigid bodies. Blender exporter now imports as well. And we've got a Babylon JS importer. So that's going to make some great playgrounds where you can drag and drop your physics files. So that's in the final stages, just getting it reviewed for Babylon team, hopefully who will support it officially. And then we've got a call to action like the extension prefix. I know this bothers Adam. Our extension prefix is currently MSFT. I'd love to make it EXT or KHR someday, but it requires multiple vendor support. So if there's anyone that's considering implementing it or wants to implement it, I'd love to hear from you and hear from what additional work it would take in order to get people started, whether that's more documentation or samples or a fancy Babylon importer that you can look at. And I think that's it.
Can I throw one more thing onto the call to action? So about a month ago, I sent out an email to the MSF, this group here, and it highlights some of the differences between the OMI physics spec and the Microsoft physics spec. And I think that OMI has made its case well, and Microsoft Eoin has made his case well. We need more stakeholders to actually get involved, review, come to look at the bulleted list that I wrote of differences, look at our specs on GitHub, both the OMI and the Microsoft spec, show up and see if it's going to work for your use cases. OMI's tried to be very careful about this. We have like charts of how to implement it across different physics engines, and we're trying to only put things in our spec that are going to be highly portable. So the OMI spec is actually way smaller than the Microsoft spec, and we need to get more people involved on this, basically. So please, if you're interested in physics in glTF, please go check out that email, go look at our GitHub repos, respond to the issues that have opened on the Microsoft repo, respond to our Kronos pull requests.
Maybe drop a link to your GitHub repo in the chat for people who might not have seen the email.
Okay, I could also, I don't know, resend the email. Is the email the best way to get in to send something to the whole group?
So for this group, yeah, that email will reach everyone. But there is a conversation happening in the chat right now about kind of the best asynchronous communication channel to keep this going. And Adam, I appreciate it. It's 9 p.m. and thank you so much for staying so late. So maybe could we just take a minute or two to talk about kind of where you guys would want these conversations to continue?
We want them to continue on GitHub and more meeting time and MSF as well.
So does that work for folks? I certainly love GitHub myself, but up to the group.
Yeah, I don't mind, like a GitHub forum or something. Mm-hmm.
Yeah.
Oh, also for anybody who missed the email, I've also posted the same bulleted list on the MSF Discord server. So please go there to respond as well. That's instant messaging is great for quick discussion.
I see you've noted in the chat that there's competing glTF physics standards. So I guess the topic particularly that you're asking about is OMI versus the Microsoft spec. So I suppose the ASWF USD Slack is not the place for that conversation.
Anyway, I just copy pasted some excerpts from the email into the chat here, but I've also, the same text is on the email and it's on Discord, so please go read it there too. And that way you could actually respond, and your response will be visible for not just the one Zoom call.
Okay.
Yeah,
Yeah,
we
yeah.
should
Go ahead, Mark.
get some resolution at some point, because purpose of this conversation is not to arbitrate what's the right thing for glTF, but make sure, we have compatible solution for USD and glTF. So,
Well, I'm not saying that MSF needs to like officially arbitrate and like hardline any of these things. I just am using this as a forum to try to convince each individual in this call to show up for these discussions. Hope that makes sense.
okay, makes sense.
Cool. Well, yeah, I hope we got a lot of conversation going on there in GitHub, and we'll keep this thread rolling. So what I'll do, I'll stop the recording.